Now, chapter 1 was all about ax plus by equals c, or y equals mx plus c. What's the name of this equation? Jeffrey, you can tell me. Y equals mx plus c. What's the name of this equation?
Y equals
mx plus c.
Equation.
Your friend Young will tell me.
Linear equation.
Yeah, linear equation. What we're going to look at now is this one. Who knows the name of this equation? No one knows? That's okay. I didn't expect you to. Quadratic. Oh dear, something's wrong with my pen. Quadratic equation. Quadratic equation. Now, really important, A, B, and C, they can be any real number, but you can't really have A to be 0. So that's the only exception. Why did I say that? Why am I saying A is not 0? Any ideas?
If A equals 0, no x2.
No x squared. So then it's not quadratic, it's linear then. So I'll just forget about A being 0. A is not 0.
Yeah.
Okay. Now, we're not going to do it today, but I know you might remember from high school the formula minus b plus and minus square root b squared minus 4ac over 2a. Does that sound familiar from high school?
Yeah.
Yeah. Now we'll do that later, but for today we're going to look at something called completing the square. So I'll give you a little bit of a multiplying example first. Suppose I have a plus b and I want to square it. There's a quick way and a long way to do it. The long way to do it would be to write it like this. And then what do? Multiply. A by a squared, and then ab, and then ab again, and then at the end, b squared. That equals a squared plus 2ab plus b squared. So that's a plus b squared. In fact, if you want, you can just jump straight to the answer. You'll notice that the answer is the first one squared plus twice the first by the second plus the second one squared. It's always going to be this. So for example, if I had like x plus 2 squared, what would that be? X squared
plus 4x plus 4.
Okay. Now this looks like a quadratic, and it is a quadratic, and in fact, for all your quadratics, you can write it back into something like this. And this is called completing the square. I'll give you an example. Suppose I gave you this quadratic, x squared plus 4x plus 14.
Yeah.
That's very similar to this, but one exception. What's that?
X plus 2 plus 10.
No, well, what's the difference here? It's 10, yes. So this is the same as this, except it's 10 bigger. So that means the answer here will be the same, except for I need an extra 10. My point is, on my page, it doesn't matter what, if you have some quadratic, any quadratic like this, you can always write it like this, with some number here plus some other number. This is called completing the square, and I think it's actually in the questions there. If you see there, the very first question, complete the square. Can you see that? So let me show you an example how you can work backwards. Well, there's a trick to it. Let's say x squared plus 6x plus 9. Okay. First thing you do is you take the 6 and you make half of it. So what's half of 6? 3. So then you write here x plus 3. So you take whatever this number is here, with the plus, you half it and it goes there. Is that okay so far? Or just half it goes there? Oops, where's my... Okay. Next, what you do is, oh actually, let me make this one 19, make it more difficult. Okay, then what you do next is you take the 3 here and you square it. What's 3 squared? 9. What do you need? 19. So am I too small or too big?
Too big.
No, too small. Here is too small, I mean. This is 9, but I need 19. How far away am I? I'm 10 away. I need an extra 10. And that's it, that's the completed square. And you can check, if you multiply this out, you will get this back here. Let's multiply it out to check. So this is just checking the answer. What's this going to be when I square it? X squared plus 6x, 9 plus 10, and then 9 plus 10, 19. So this and this, they're exactly the same. This is just called the completed square of this. Let's look at one that's a little bit more difficult. Let's say with a minus. X squared minus 4x plus 1. Okay.
X minus 2.
X minus 2. How did I get that? It's half of this.
Yeah.
That's okay?
Yeah.
Right. Now what's minus 2 squared? 4. 4. It's more than what I need. I only need 1. I'm too big. So what do I need to do? Take away 3. And now it matches up. Because here, what's minus 2 squared? 4. But I need 1. So I'm 3 too big. So I need to take away 3.
You need 1.
Yes? I need 1, yes. Right. I'll give you one to try. I want you to write this down. So this is your one to try. X squared minus 6x plus 20. You got it? You got this? Yeah?
No.
Yeah. Did you get this? Yeah? Do you have it or don't have it?
Whatever you check, but I can.
Okay, you want to see, okay. But you have tried an answer, yeah, okay. So, oops. Okay. So you can tell me what you got. Go ahead. What did you put in here?
X minus 3.
Minus 3 squared. Now, what did you put at the back here?
Plus 11.
Plus 11's right. Because minus 3 squared is 9, but you need 20, so you need an extra 11. Okay? Good. Now, why are these completed squares so useful? So let's take this example here. Y equal to this. Okay? If you look at this here, what's the smallest y can be? Y minimum, the smallest it can be.
11.
11. Why?
0.
No, but that's not a sentence. Why is 11 the smallest y can be?
X minus 3 square. The minimum
Yes.
is 0.
Yes. Why?
Always positive
Why?
number. Square.
Thank you. So, this here is square. Square numbers are always positive, right? What's the smallest it can be? It can be 0. So, the smallest y will be this number here. That'll be the smallest y. Now, that's 11. I said the smallest is when this is 0. So what value of x will make that 0? What do you put x equal to make that part 0? 3. Because 3 minus 3, 0. So my point is, if you have y equals x minus a squared plus b, the smallest point will always be a, b. So when you complete the square, the two numbers you get will be the smallest point on the graph. It'll be that point. That's the shape of a quadratic. I think you should all remember this, I hope, from high school. But there is another way the quadratic could be shaped. What's the other way it could be shaped? Yeah, like this, a hill shape. When will it be a hill shape? When is it this type of shape?
Minus.
What's minus?
X.
Yeah, if you had something like minus x squared plus 2x plus 1, then it's not a minimum. Instead it's a, what's the opposite of minimum? Jeffrey?
Huh?
The opposite of minimum? Minimum and?
Minimum.
Minimum and minimum? Minimum and maximum. Okay? This one's a little bit different to the examples I did, because in my examples I had only x squared, but what have I got here? Minus x squared. Does anyone have any ideas how I could do this the same way as before, but fix it first?
Multiply.
Not multiply by minus.
Minus. Out.
Minus out, yes. You can take the minus out. So if I take the minus out, what am I left with? X squared
minus 2x.
Yeah.
Minus 1.
Minus 1. Like this. I took the minus out into the front.
Okay.
So then all the signs got changed.
Okay.
Yes? Now let's do it like before. Okay. So, let's see. Schofield.
Yes.
What do I have here?
X minus 1.
X minus 1. And then Young? What's minus Young? Minus 1 squared? Minus 1 squared? What is it? Do you understand me? Minus 1 squared. You know squared is 1. But what do I need? Minus 1. So am I too big or too small? Too big. So I need to take away. Take away how much? Minus 2. But I'm not finished yet. Don't forget about the minus here. So I get minus x minus 1 squared plus 2. So what's my point? 1 and 2. There's 1 and there's 2. So on this example, the point at the top here is 1, 2. There's a name for the maximum and the minimum. Does anybody know it? Does anybody know the name for this point? This point here and this point here? They have a name. Does anyone know? They're called vertex. Is this a new word?
Yeah.
Yes? Okay, so write that down. It's called a vertex. Or another name? Turning point. Both are called vertex or turning point. It means the point that's on the top or on the bottom. Okay, are we happy with that? Can I just have a look at the questions? I don't think they're too difficult now.
And I have another type of this. Another type of this.
Another type of these?
Yeah.
What do you mean? There's one where there's a number in front. Is that what you mean? Like number 4?
Number 2.
Number 2?
Yes.
Oh, number 2. Yeah, okay. I'll do 2A as an example. So, Alison, can you just read out? No, it's Alison, isn't it?
2A.
Yeah.
3 minus 6x
3 minus 6x
minus x squared.
minus x squared. That equals minus x squared minus 6x plus 3, right? I mean, it's still the same. Minus x squared, minus x squared. Minus 6x, minus 6x. Positive 3, positive 3. But now I take out the minus. So Alison, you can tell me what do I have left inside if I take out a minus. So what's first?
X
Yeah?
plus 6x minus 3.
That's it. Okay. Now, maybe one of the Abdul or Abdullah, you can tell me what I get now. So what do I have here?
X squared.
X. What's the next number? I'm going to write it like this, I mean. So x plus
3.
3 squared. Now 3 squared is 9,
No,
but I need minus 3, so I'm too big.
yeah.
How much am I too big? I'm 12 too big, so minus 12. I just need to put the minus in to finish now. So I get minus x plus 3 squared plus 12. So my point is going to be, what's my point? Minus 3 and 12.
No, this was read another way, the 12 at the first.
Oh, okay.
12
Yeah, it's the same thing then. If you want to write as 12 minus x plus 3 squared, but that's exactly the same. If that was the exam, I'd still give you full marks. Okay, so don't worry too much about that. Yeah?
Just go up on that.
Yeah.
Okay, move down. Okay.
Yeah.
Okay.
Here?
3 squared is 9.
Yes.
And 9 and minus 3.
What you need to picture is you have 9,
Yeah.
but you want minus 3. So you're too big. So what's the difference between minus 3 and 9? So minus
6.
No, you're adding them together. Minus 3 to 0, how big is that? How many units?
Minus 3.
Minus 3 to 0 is 3 units.
Yeah.
3 units. Minus 3 to 0 is 3 units. And then 0 to 6?
0 is 6.
Yeah?
6.
6, so 6 units and 3 units. Do you know what I'm saying? I'll draw it here. You have 9. Oops. So you're here. But you want minus 3. So you're too big. How much too big? Well, here to here is how much? 9. Here to here is 9. And then how big is here to here?
3.
3. So in total, you're 12 units too big. So you have to take away 12. Yes? You seem a little confused. I can do another example. Would that help? Yes? Okay. So you have x squared plus 6x. Now I'll do an example where I'm too big, so minus 2. So what do I have first? X plus 3 squared. What's 3 squared? 9. But I want minus 2. So here's minus 2 and here's 9. What's the difference between them? 11. So you need to remove 11.
Okay.
Whoops.
Okay.
Okay. That's really it. There's two main things to this. Writing it as a completed square, and then once you've done that, they could ask you what's the point then, vertex. So in this example, what would be the point? would be for this one?
3.
Yeah, I mean, not quite 3, you always have to change the sign of this one. It's going to be -3 and -11.
Oh.
Now the reason for that is, if you think back, I said if you have x minus a squared plus b, the answer is ab. But this is a plus, not a minus, so you have to change this sign. This one you don't care about, so it just stays the same. You don't care about this one. But this one needs to be changed. So like here, this is a plus, no sorry, yeah, it's a plus, so you need to make it a minus then. And then maybe earlier, here was a minus, so it's fine. You can keep it as the 1 then. Like a -1, it means x is 1 then. But if this is +1, then this is -1 then.
Yeah.
Okay. Do we get the idea to this? Yes? Good, okay. I don't think they're too difficult. I did a few examples and it seems like you all understand it. So you can try these for a few minutes and then we'll start the next lesson. Let's stop recording.